Hello everybody, thank you for coming. Today I'm going to try to talk with you about building your prototype and getting it all the way to the production in just 20 minutes. Let's see if we can do that. First about me, I started working as a software developer almost a decade ago. My first journey into programming was with JavaScript, which made me choose Python and never ever look again to the front end side of things. I also own a small company, Softwareific, and we do some pretty cool stuff with Python, as well as software consulting. It might seem quite obvious to all of you that if you want to build something very fast, you need to know what are you building. But usually when we talk with clients, we get, oh yeah, that's correct, and we're thinking about the same thing, so all is clear and we can start building. And somewhere along the way, when we get some demos going, client is going to start saying, but that's not what we talk about. We talked about something completely different. There are lots of problems in communication that can happen. So it's very important to everybody knows what you're building and everybody be on the same page. Even though usually people say, yeah, I understand what's going to happen. So in order to help us avoid having to recode large portions of our code base, we're going to have to start way before actual coding. Now, prototypes are pretty awesome. They're gonna help us avoid misunderstanding and make sure we all know what we're building. Now, as a software developer, you might think, oh, prototype is just a simple website that displays some basic functionality, sort of a MVP. I learned the hard way that this is not usually the case. Depending on your client and their area expertise, prototype is going to mean completely different things. One time I was working with a client who specialized in embedded software and hardware development. So when I was talking about building a website prototype, he gave me a very strange look and told me, "That does make no sense at all. Why would you want to build electronic boards for a website? It's gonna take us a few weeks to get everything from the factory." For them, prototype was basically hardware. For designers, prototype can be a little sketch on the paper, which leads me into our next segment. Do not be afraid of the paper. Paper itself is worth its weight in gold and then some more. It's very helpful in the beginning phases to just make a rough sketch of how things should look, and it helps you and your client to understand what you're talking about, and once again to make sure you're speaking the same language. One good thing about prototyping is with paper is that if you mess something up, you can just grab another piece of paper and resketch it. So it takes only a few seconds to fix errors here. If you want to do that in the later phases of the project, well, it's gonna take more time. If you are already starting doing some design and you detect some problems, it's gonna take a few hours. If you are already doing deployment and your code is written, any errors in user flow you detect, then it's going to take a few days or weeks to fix. So love your papers and draw. Now, it doesn't have to be nice, it just needs to be able to convey a general idea, what are we building, and to get some basic user flows to make sure everybody is doing what it's supposed to. Myself, top of my artistical talents is drawing stick figures. and it's perfectly fine for these sorts of jobs, so don't be shy. If I can draw some prototypes and not be ashamed of them, you can do it too. Now, one very good advice is to be nice to people in general, but especially designers. They're doing the hardest part of the project. Now, I know lots of programmers are gonna give me a weird look. How are designers doing the hardest project? We're programming and all the stuff. Well, they're talking with clients, and I haven't met a single person that didn't have opinion about the design, regardless of their background. In programming, you usually have sort of a entry bar where you know some things about coding, you know how things should look like, and then you can give sort of opinion. In design, everybody has opinion about it, and everybody is telling your designers how they should do their work, which is very hard and stressful for them, so be extra nice to them. Now the thing, for example, let me share one of the stories. We were doing some demo for the client, and during the middle of the project, we discovered that we need to do complete redesign of entire product because client's 5-year-old didn't like our website. And I'm so proud of our designer that managed to create a new design and not go crazy. Imagine doing the same thing but with your backend code. Also, work your designers are gonna do on refining the prototype is absolutely priceless. They can use Figma for perfecting UX, for making sure a client can see some functionality and how it will behave without any actual code. Now, regarding Figma, I'm gonna use it as an example here, mostly because I'm forbidden from doing any design work, since I can name maybe 8 colors. But my designers told me Figma is good and they love it, so I'm just gonna talk about Figma. That doesn't mean it's the best tool about design, so I'm talking from the perspective of a programmer who knows some designers who know their job. Now, when we start project, usually everybody is super hyped up, especially clients and engineers, and we all want to start building stuff. And that's our first impulse, and it's usually quite wrong. You need to, as I mentioned before, define your prototype and make sure you have clearly set up what is your MVP. And then there comes a very important step that we miss a lot of the time. You need some person, usually that's product owner, project manager, anybody who can use the secret superpower of common sense to go over everything and see, does this make sense, and maybe take a look at the competition, figure out features, what we need to improve, what works in the current form, what doesn't work. As I mentioned, very good tool here is that we use with our client is Figma. That way client can see some website functionality, see what happens when he clicks on a button, see scrolls, see how it will look on mobile phone and stuff like that. And then once everybody's super happy and satisfied, only then we can actually start coding. Now, yes, we are about middle way to our presentation, and only now I'm gonna start talking about coding. And I was debating with myself if I should do it even later. it's very important to do your preparations for the actual project, because as I mentioned before, fixing stuff in your code that was improperly designed or defined earlier is going to take you several magnitudes of time more than if you did that on the paper or design. So don't rush. Everybody loves coding, but you need to do it at the right time. And here's one of the very interesting facts. The further you are from the client, the more you're gonna be in your job without any disruptions. Closer you are to the client, there's going to be much greater frequency of the change. Design that's the component that's going to change the most, usually several times a day. Front-end and mobile apps, they're gonna have lower frequency, because usually once something goes to the front-end development, it already went through the several iterations of design. Backend, well, as a backend developer, you're probably gonna change much your code with less frequency than a front-end developer. And DevOps, those are the cool guys that set up message queues, database, server infrastructure, permission in AWS, cloud deployment, all the crazy stuff. They're probably not gonna have frequent infrastructure changes. So, further away you are from humans, less stressful your job is. Unless things go wrong. Then it's every man for itself. Now, since most of us here are Python developers, that means hopefully we are working in the backend development. And our main job is going to be to connect front end with DevOps segment of their area of expertise. Database, message queues, all the crazy stuff. And the most important part of that journey is going to be how we communicate with each of them. We want to make a clean cut between us and front end, and very nicely defined border between us and DevOps. That way they can do their stuff and we can do ours without affecting each other. With that in mind, in order for front end and back end to communicate nicely, you need to define how you're gonna talk to each other. And that means having API documentation. One thing you should know is that your front-end developers have a lot of work on their hands. Every day they have to deal with JavaScript and CSS, and people who can do that, they're very scary, and they have pretty much nothing to lose, so you don't wanna make them angry. And first step in doing that is to have a good API documentation. That way they're not gonna show up at your door at night. And since we're all humans, we need to avoid manually updating APIs, because speaking from experience, every time I had to update manually API, at some point in time I completely forgot, oh, I made a change, I need to edit API, I can do that later. That later never came. So with that in mind, try to auto-generate API documentation. Luckily, as Python programmers, we're kinda lazy, so we got lots of awesome tools to help us with that. I love using, for example, Fast API, because everything I change, it's automatically reflected in API documentation. I did a little bit of work with Django REST framework, which has ability to do the same thing, but I think you can find that for whichever is your web framework of preference. But try to write as less as possible and make your code to do most of the work for you. So once again, laziness is a virtue here. With that in mind, we can start communicating with our databases, message queues, everything that is backend of our backend. Here things are going to be a bit different because you are not going to have API from your DevOps team. In order to make sure you're doing things correctly, you're going to have to build something similar to API, and that is using abstractions that define our communication towards those objects. We're stealing this from Java developers. They've been doing this stuff for decades and it worked quite nicely for them. Basically what we want to accomplish here is since infrastructure of your project when you start working on it and infrastructure at the end, that's going to be two completely different things. For example, at the start of a project you might be using SQLite, then at some point you might move to PostgreSQL, then later to Amazon Aurora, or maybe some NoSQL database. What we want to accomplish is that every migration to another service in the background changes our code as little as possible, and we want to localize those changes, which is where abstractions come quite handy. Here we can see an example of that. We can define abstract class that we're going to call database provider, and as soon as some segment of our code needs something from the database, we just add that method to database provider. Now we want to make sure that everybody who does concrete implementation of this this class is going to provide actual methods. So your SQLite provider is going to inherit database provider and implement, for example, get user information method that we defined in database provider. We can do this for PostgreSQL provider as well, and any other type of database. Now, once you start working with your code, you can just plug your provider with which you are currently working, and you don't have to change anything anywhere else. Also, one of the good sides about all this is that you can very easily test it. It's super easy to just create your own mock database provider, inherit database provider, and you know what methods you need to implement, and then test the functionality of the rest of the system. When you implement concrete provider, for example PostgreSQL provider, you're just gonna focus on your testing on that concrete provider to make sure methods are doing what they are supposed to do. The rest of the system is going to function the same way. What we want to accomplish is that our system is completely agnostic about what is the concrete implementation of that database provider. Type hints are pretty awesome here because with them our code is going to complain, MyPy is going to complain when we start using incorrectly methods. So use type hints, they can help you quite a lot. Now here's something that everybody is talking about, but sadly I've seen it ignored quite a lot in practice. Usually people think, oh, it takes too long to write tests, or I can do without writing tests, it's not that hard. And yes, I'm gonna tell something that probably you didn't expect to hear, but yes, sometimes it's faster to just deliver the code without tests. This only works for a throwaway code. And in my experience, throwaway code is never throwaway code. If you make a prototype website that is put quickly together with glues and sticks in the background, client is gonna assume, oh, this is perfectly fine, and that throwaway code is gonna become your code base for later development. So resist the temptation of not writing the tests. It's almost impossible to grow your code base without tests. I've seen examples of that, and that was usually just one person doing that, and the moment they move from a project or when they needed to onboard somebody to help them with the workload, it was almost impossible. Doing development in team, as most of us do, without tests is gonna waste lots of time, because tests are gonna catch a huge number of errors. So when you have changes and you commit a specific branch, you just run the tests, and tests are gonna detect if everything is working nicely. And then you create your pull requests, where somebody is gonna review the code and make sure everything is nice. Lots of this stuff can be automated, which is quite useful and handy for us. Now, also refactoring. No matter how good your code base at the beginning is, as your system grows and develops, there are gonna be some point in time when you're gonna need to refactor certain portions. And doing that without tests is almost impossible. With tests we can change huge portions of our code and be sure that we didn't break anything. So write tests, because without them you cannot develop quickly, even though it might sound easier to just write the code. Thanks everybody for having me here, and if you have any question for me, I'll be sticking around, so feel free to reach out to me. Bye!